Hello, this video is about linear inequalities and specifically how to prove solutions mathematically using linear inequalities. So some basic things that we need to know before we begin. First, a linear inequality is an inequality, so a less than or a greater than, less than or equal to, greater than or equal to, an inequality. And when we graph this inequality, it's going to make a straight line. And then, hopefully, we already know that when we graph linear inequalities, we have some shading. So for instance, if it's a less than symbol, my shading would be all beneath the line, saying that everything inside the red area is a solution. So this purple point is a solution because it's in that shaded area. So is that purple point. So is that purple point. However, points outside the shaded area, like that yellow point, or this one, are not solutions. But what we're going to be dealing with in this video is how do I prove solutions mathematically? So if I don't have a graph and I just want to show using math if something is a solution or not. So which ordered pair below is a solution to the inequality y is less than or equal to 3x plus 5? And we have two ordered pairs here. So let's handle the first ordered pair, -4, 1. If you remember, this is x and this is y. So in my inequality, I'm going to replace the y with the number 1. It's still a less than or equal to symbol. I have my 3. But now instead of my x, I'm replacing it with -4 plus 5. And to prove mathematically, I want to make sure that it makes a true statement. So this 1 stays the same. My less than or equal to sign stays the same. Now I'm just going to calculate. Well, 3 times -4 is -12, plus 5 is -7. So now we need to ask ourselves, well, is 1 less than or equal to -7? Is this statement true? Well, 1 is not less than -7. So that means that this point, -4, 1, is not a solution. It would not be in the shaded area of that graph. But let's look at the second ordered pair, 2, 11. So again, my first number is x, my second number is y. So in my original inequality, I'm replacing the y with 11, replacing the x with the 2. And I'm going to do some calculations to see if it makes a true statement. 3 times 2 is 6, plus 5 is 11. So let's look at this statement. Is 11 less than or equal to 11? Well, yeah, it's equal to. And because my symbol is less than or equal to, it's okay that they're equal. Sometimes it's not going to be okay for them to equal. But this time it is because my symbol is less than or equal to, which means that this ordered pair, 2, 11, is a solution, meaning that point would be in the shaded area. Let's look at one more example. Which ordered pair below is a solution to the inequality -2x plus 3y is greater than 6? So again, I'm going through, my first number's x, my second number's y, and I'm replacing, just putting right in where the x was and where the y was. And now I'm going to do some calculations. I'm going to take this one a little slower. -2 times -6 is a positive 12. 3 times -2 is a -6. Now 12 minus 6 is 6. So we have to look at this final statement. Is 6 greater than 6? Well, no, 6 is actually equal to 6. But my symbol only says greater, and 6 is not greater than 6. So this is not a solution. And this last ordered pair, 3, 5. So 3 is my x, 5 is my y. And again, if I go through and replace what I need to replace, -2 times 3 is -6. 3 times 5 is 15. Negative 6 plus 15 is 9. So look at this final statement. Is 9 greater than 6? Well, yes, 9 is greater than 6. So this is a solution.